Welcome class 10. In today's video we are going to learn about characteristics of sound. There are three different characteristics of sound and they are loudness, pitch and quality. Because of these three characteristics, we can easily distinguish between two different sounds. Let's talk about loudness. The loudness is the characteristic of sound which helps us differentiate between a loud and a soft sound. A loud sound may be represented by this kind of wave, and a soft sound is represented with this kind of wave. You can see the two waves have the difference in their amplitude. Other than that, both the waves look similar. In the first one, in this one, in the loud one, you can see the amplitude is quite large, and in case of soft, the amplitude is quite small. So when there is large amplitude of a sound wave, then the loudness becomes higher, and if the amplitude of the sound wave is less or small, then the sound will be softer. So large amplitude will have loud sound and small amplitude will have soft sound. But this idea of how much loud and how much soft depends or varies according to varies for different persons. So it's up to you whether you decide it's loud or soft. Anything louder for a person may be not loud enough or may be soft enough for another person. So it varies person to person. So that's why this topic, loudness, is considered as a subjective characteristic because it depends on the listener. Thus, we define loudness as the loudness is the characteristic by virtue of which loud sound can be distinguished from a soft one. Next, there are few factors that affects the sound. The factors that affect the loudness of sound. Number one, loudness is proportional to the square of the amplitude. As we have seen in the previous picture, in the previous case, that if the amplitude is large, then the loudness of the sound will be high, means the sound will be loud enough. And if the amplitude is low or small, then the sound will be soft. It will not be loud. Thus, we can say that loudness is directly proportional to amplitude, but it is not only directly proportional, but it is proportional to the square of the amplitude. Mathematically, we write it as loudness being proportional to amplitude squared. This means simply that if you increase the amplitude 2 times, then the loudness is increased by 4 times. Square of 2 is 4. So amplitude increases 2 times, loudness increases 4 times. Similarly, if amplitude increases 3 times, then the loudness will increase 9 times, and so on. Similarly, if you decrease the amplitude, then the decrease in loudness also becomes the square of the amplitude. For example, if you decrease the amplitude by 2 times, then the loudness is decreased by 4 times. Similarly, if the amplitude is decreased by 3 times, then the loudness is decreased by 9 times. Okay. Second factor in which the loudness varies or depends is the distance from the source of the sound. So loudness varies inversely as the square of distance from the source. Inversely means if you increase the distance, the loudness will decrease. So inversely means if one increases, the other one decreases. Mathematically, we write it as loudness being inverse to distance square, or loudness varies as 1 by distance square. This means that distance, if it increases 2 times, then the loudness will decrease 4 times. If the distance increases 3 times, then the loudness decreases 9 times, and so on. The next factor is loudness also depends on the surface area of the vibrating body. If the surface area of the vibrating body is large enough, then the sound produced will be larger. Okay, larger the surface area of the vibrating body, louder is the sound heard. This is the example which we can give is like if you bang the desk, you people know that it produces a loud sound. But if you bang an exercise book with same intensity, means with same force, okay, the sound produced by banging an exercise book does not give that much amount of loudness or that much amount of sound. So here the desk used has larger surface area compared to the exercise book, hence it produces larger sound or louder sound. Another example is like in churches and in schools, big bells are kept, so it produces large sound. Okay, if you have small bells, in order to ring for some kind of purposes, for some purpose, then the sound produced won't be that large. But in churches and schools, if you have seen big bells, then those bells are kept so that it produces large sound. Next factor, number 4, is loudness also depends on the density of the medium. More the density of the medium, louder will be the sound. Okay, if the density is more, then the sound produced will be louder. Similarly, if the density is less, then the loudness of the sound will be decreased. All right. Example we can say is in comparison to air, the sound is more louder in liquids, and in comparison to air or liquid, sound is more louder in case of solids. Number 5, loudness also depends on the presence of resonant bodies. This means that you have already learned about resonance. If the resonating bodies are kept nearby the vibrating body, then the loudness increases. So the presence of resonant bodies near the vibrating body increases the loudness of the sound. So these were the 5 factors in which loudness depends. All right. Next, we move on to the unit of loudness. So unit of loudness is phone, PHON, it's not PHONE. And also its unit is decibel. In short, we write it as D and capital B. It's not small d, small b. It is small d and capital B. In science, when we talk about 0 decibel, for example, if we have to give some examples, then 0 decibel is supposed to be no sound. But in physics, there has been an understanding, or people have taken this as 0 decibel sound to be as the faintest sound that is ever produced. Ever produced. I would like to say ever produced. That is the pin drop. That's why the teachers would say maintain a pin drop silence in the class and so on. Okay. So pin drop in science is considered as 0 decibel. Similarly, we move on to the higher decibels. Then when you whisper, the way you whisper softly is considered as 30 decibel. When you are talking normally, like I am talking to you, normal conversation is about 50 decibels. And when the jet takes off, okay, it will produce 140 decibel of sound. Any sound which is above 120 decibel is also considered as noise, which causes headache and also can damage our hearing property or our ears permanently. So it's only good to hear softer sounds, and in order to have safe sound we have safe limit, that is we can hear easily or safely between 0 and 80 decibel. Above 80 decibel it starts hurting, and if you hear the sound more than 120 decibel it will cause headache and also can damage your ear permanently. Usually music or sound up to 30 decibel is considered very soothing. Okay, when you have to enjoy some good music, then you should only listen up to 30 decibel, not more than that. Okay, suppose you are in disco and if you are having a nice party with loud sound, then that sound is not 30 decibel, it is more than that. You cannot hear normal conversation when you are inside a pub. Means when you are in disco, you won't hear your normal conversation which is of 50 decibel. That means the sound in disco when you are having a good time party and dance, it is more than 50 decibel. So it's up to 80 decibel when you are having a good loud sound of music, and that's not soothing. All right, next we move on to the most important factor. It's called the intensity of sound. Now what is intensity? Intensity is something which we would like to say as objective. Objective is like the in previous case I said that loudness is subjective, it depends on person to person. Now intensity is objective. Objective means it does not depend on person to person. If I say it's loud and for you it may not be loud enough, but intensity is measurable, that's why it's not considered as person to person choice. So it's better we take it as measurement, because if the measurement says it's some value like 10, then it's 10 for everyone. It's not 9 for you, 8 for me and 5 for some other fellow. Okay, objective measurable means it remains same for everyone. So what is intensity? The amount of sound energy passing per second perpendicularly through a unit area is considered as intensity. So let's see how it looks. Look at the figure. When there is a source and it is producing some amount of sound, and if that sound passes through this much area of unit area, then the amount of sound that produces per second, means in 1 second how much sound is passing through. Over here you can see it's just the explanation in a with the help of a drawing, so don't take it that practically the sound will drop out here in this way. No, it's just the it's just the explanation part. Okay, in 1 second the intensity falls in this particular area, and that much is the amount of sound collected. And in high intensity means uh, more sound waves will be passing through the same area in 1 second. So this is intensity, this is high intensity, and this is low intensity. More the intensity, more louder will be the sound, and less the intensity, uh, less louder will be the sound. So that is very clear, right? So mathematically, how do we understand intensity? Intensity is energy passing through per unit of area in per second. All right, so energy per unit of area in per second means in 1 second how much amount of energy is passing through 1 unit of area. So energy is written as joule, area is meter squared, time is second. Now we know that joule per second is represented as watt, and meter square is there in the denominator. So intensity is in short represented as watt per meter squared. So greater the energy of the sound, or greater the sound energy, greater will be the intensity of the sound. Now how much is 0 decibel? 0 decibel is the amount of sound energy that has 10 into the power minus 12 watt per meter square. So 0 decibel is that much amount of sound. Just remember the value 0 decibel is equal to 10 to the power minus 12 watt per meter squared. And when you want to increase from 0 decibel to 1 decibel, the increase is 26% of whatever the sound intensity was there in 0 decibel. Okay, 1 decibel is equal to 26% increase in 0 decibel sound. So 1 decibel sound, this is very important. The definition of 1 decibel sound is the increase in level of loudness when the intensity of sound increases by 26%. That means if there is increase to 2 decibel, then it should be 26 plus 26, 52% increase. Okay, so 1 decibel is 26%, 2 decibel will be 26 plus 26, 52%, and 3 decibel will be 26 plus 26 plus 26. 4 decibel will be in the same way it moves on. All right, so this is very important. You need to know 1 decibel is defined in this way. Next part we move on, and it is about the next characteristic of sound, that is pitch. Let's see the definition of pitch. Pitch is that characteristic of sound by which a shrill sound is distinguished from a grave or flat sound. Here, shrill sound means something with very high pitch, like screaming. Alright, when you scream, the sound produced is a shrilling sound, and a grave or flat sound is like the sound which you have in bass. Okay, so usually we can say that a bass or grave sound will have low pitch, like if I say a bass is like and treble is like okay, so treble or shrill is high pitch. So different frequencies have different pitches. So low pitch will have different frequency, and high pitch will have different frequency. Just like in case of loudness, it was the amplitude that that actually, you know, that actually showed uh, the loudness would vary with the amplitude. All right. Over here, in case of pitch, it's the quantity that matters over here is frequency. So with different frequencies, you'll get different pitch. Same instrument can have, different different pitch, although the loudness remains the same. For example, if you play guitar, if you know how to play guitar, then you might know, or any other instrument, guitar sound can produce different notes, and all these notes are different. Okay, because they are different pitches. So different notes with different pitch have same loudness and the same quality. Although when we hear to this guitar sound, we can uh, make the difference between two different notes. So this is why, because the pitch in the sound of guitar are different. Sometimes it is higher notes, high pitches, and sometimes it is lower notes. So the same instrument with same loudness can produce different pitch because of different frequencies of the notes. Okay. So if the amplitude is same, the loudness remains the same. But if the pitch has to be different, then the frequency has to be different. And what is frequency? Frequency is the number of waves produced in 1 second. Okay. Frequency is the number of waves produced in 1 second, means how many waves are being produced in 1 second uh, gives the frequency of the wave. So let's have a look over here. There are two waves, both produced from the same source, but you can see the difference in the wave. Both the waves also are having the same amplitude. Amplitude means the height from this portion to this portion. So this height over here is amplitude, and this height over here is the amplitude for this wave. So both the amplitude looks similar or same, but what is the difference? Let's draw a line which shows that, from here to here and from here to here, how many waves are produced in the first case and how many waves are produced over here in the second case. So in the first wave, if you see from here to here, if you consider as one wave, then from here to here there is another wave, that makes total of two waves. Okay, let's say if this interval from here to here is 1 second, then according to this wave there are two waves produced in 1 second, and for this wave down there are 1, 2, 3, 4, 5, 6, 7 and half. Okay, 7.5. So which is much more compared to this wave. So over here two waves are produced in 1 second, and here 7.5 waves are produced in 1 second. So the frequency means the number of waves produced in 1 second. So in 1 second the frequency over here is 2 and the frequency over here is 7.5. So this means that this wave has more frequency compared to this wave. So in comparison, compared to this wave, the pitch of this wave will be high. That means it will have more shrilling sound, and this wave, since its frequency is less, so its sound will be grave. It will not be shrill. So difference in frequency actually makes difference in pitch. So higher the frequency, higher is the pitch. That means it will have more shrill, and lower the frequency, lower is the pitch, and it will be grave. Now let's talk about some examples. If you are, if you take a, a, a stringed instrument, okay, frequency of the string instrument depends on length, thickness and tension of the string. So how does it depend on length? Shorter the length, higher is the pitch, means higher is the frequency. More thickness, less is the pitch, means if the string are more thicker, then the pitch will be less. We know that in guitar, the, you know, if the thickness of the string moves, if the thickness of the string is increased, then the sound produced will have more bass, means its pitch will be less. For example, if you are talking about the sixth string, it's quite thick compared to the first string of guitar, right? So this is how the thickness and the pitch. So more the tension, higher is the pitch. Next, in flute, longer the length of air column, lower will be the pitch. Okay, if the air column increases, then the frequency will decrease, so its pitch will be lower. In a pitcher, you know, pitcher is a vessel where the waters are kept. All right, so water level when rises up, air column decreases in a pitcher, so its frequency increases, thus the sound will be shrill. So when if you hear the tap is on and the water is falling down to the pitcher, and without looking at the pitcher, you may hear the sound and you may know that the pitcher is about to get full. Okay, the water level is rising and it's about to get full. Okay, so water level, only by hearing the sound from distance will come to know whether the pitcher is about to get full or not. So this is actually because the pitch of the sound depends on the air column of the pitcher. So air column decreases, then the frequency increases, means the pitch will increase. Again, pitch is a subjective nature. All right, this means that pitch depends whether it's high or low. It depends person to person. Anything sounding shrill to me may not be sounding shrill to you. So it may be something flat. Okay, so it depends person to person, so that's why it's subjective. Whereas frequency is objective. If I say the frequency of a tuning fork is 500 hertz, then it's 500 hertz. It may not be 300 hertz for someone else, so it remains objective. Okay, so I hope you are understanding the difference between subjective and objective. Okay, next we move on to the next characteristic of the sound, that is quality. Quality or timbre, also called as timbre, is that characteristic of sound which distinguishes the two sounds of same loudness and same pitch but produced by two different sources. For example, let's say there's a guitar and there's a violin. Both of them are being played with equal amount of loudness, equally loud. Okay, and both of the instruments are playing the same musical notes. All right, same musical notes played by guitar as well as the violin. But when we hear the two sounds, one from guitar and one from violin, we can easily understand, we can easily make out that this sound is the sound of guitar and this sound is the sound of violin. How can we make it out? Because we know that this sound is the sound of guitar and this sound is the sound of violin because of their quality, because of the quality or timbre. Okay, I'll show you a few example over here. Let's see at this picture. So here there's a wave of guitar string plucked, and another one is a noise, that is cymbal crash. Cymbal crash means simply it's a crash sound of cymbal. Okay, that is one of the part of the drums. All right, so there are two different kinds of graphs. All right, so the quality of musical sound depends on the waveform. Okay, so let's look at what waveform means. Over here you can see the first one is a waveform of flute, which is playing middle C over here. Middle C is a name of note. Piano plays the same note, middle C. All right, and this is the waveform of the piano. And trumpet again plays the middle C, the same note, and it produces this kind of waveform. So you can see different waveforms of different instruments. This is because of their quality. The quality of these different instruments give different waveforms. So the sound of a musical instrument is the combination of different frequencies. No, unlike tuning fork can produce one sinusoidal wave, one sine curve type of wave. But over here, the sound of a musical instrument is not only a single wave, but it's a combination of different frequencies. So a waveform which is obtained by superposition of different vibrations, which makes the quality of the sound. So over here you can see these waveforms are the superpositions of different vibrations, and thus these waveforms are made. Okay, so different vibrating bodies have different quality of sound. Why? Because they have different types of vibrations and different types of frequencies. Okay, so these different vibrating bodies have different quality. Like for example, guitar will have different quality, violin will have different quality, piano will have different quality. And so the quality, with the help of the quality, we can recognize the sounds differently. We can understand that this sound belongs to guitar, this sound belongs to a piano, this sound is of violin, and so on. So it's all because of quality. Lastly, we would like to discuss about the difference between music and noise. Music is regular, smooth, and pleasant, whereas noise is irregular, harsh, and unpleasant. Music is produced by periodic vibrations, whereas noise is produced by irregular disturbances. Music, the sound level is low, up to 30 decibel, so that's a soothing sound. And in noise, if the sound level is high, that is above 120 decibels. In music, the waveform is regular, and in noise the waveform is irregular. It can be any kind of waveform. Example for music is the sound produced by musical instruments, those are music. Okay, and nowadays we can see a lot of people doing beatboxing and all, so that is also the sound considered as music, and it's also produced by not only by musical instruments, also by humans. Even the singers, they produce some good music, so obviously good singers. Okay, and in noise, the sound produced by some machines, aeroplanes, cars, also some people acting like hooligans in class, they also produce noise. Okay, so so these are the basic differences you need to know. And again, this idea of music and noise is again a subjective study, because something pleasant to you may not be pleasant to some other people. Okay, something which you consider as music may be noise for some other people. or maybe someone, you know, think someone thinks that the particular genre of music is music for them may not sound like music to you. So it's again a total subjective in nature, the comparison between music and noise. Okay, it's not objective, it's not measurable quantity. Over here only 120 decibels and more is objective because it's measured. Okay, up to 30 decibels. But again, if you think that 30 decibel is quite low in loudness, if you think 120 decibel is okay for me, then again it's a subjective issue. All right, so you should know what subjective and objective means. So, and these are the things that you need to know from this chapter. Okay, and we come to an end of this chapter. Please do the assignments that has been provided in your PDF format, and if there's any doubt, let me know through your mails. Thank you.